Welcome to the first lecture of this MOOC on technology for bio-based products. I would like to start by investigating with you the drivers behind the transition to a bio-based economy. Where do we stand now and what do we do it all for? What is the necessity? There are more than 7 billion people on our planet, and this number still increases every day. Together we are facing a number of challenges. We form enormous amounts of waste. Not only physical waste, but also waste that we release into the atmosphere. Buildup of greenhouse gases induces a global climate change, causing long droughts in some places and severe flooding in others. With the ice caps melting, you can see that this guy doesn't feel very happy anymore. These changes in the natural world increase pressure on ecosystems, leading to a loss of biodiversity. But despite all these changes, in the end, we still want to live. Have fun, innovate. We go to shops to buy food, clothes, household products, electronics, and many of these products use scarce minerals and fossils, while we are facing a depletion of these resources. So, where does this all bring us? The first question we need to answer is, are fossil resources really running out? So far, oil production has increased steadily over the years, and based on population growth, it should increase in the coming future to satisfy the needs. However, most forecast scenarios predict that there will be a decrease in oil production, resulting in a gap between supply and demand. And if this is not a big enough driver, you could also argue that oil will become simply more expensive. In this study, published by the US Energy Information Administration, the reference case shows a steady increase in oil price in the next 30 years. But they also predicted a scenario where the price rises even faster. The third scenario shows a more constant oil price. Of course, these are merely predictions. However, the idea that the oil price will rise is by itself enough to induce change. Then there is the climate argument. In the latest report by the IPCC, the International Panel on Climate Change, we see the contribution of different fossil resources on the concentration of CO2 in the atmosphere. We have just crossed the 400 ppm barrier. This means that already our atmosphere contains 1.5 times more CO2 than before the Industrial Revolution. There are different scenarios for how long this will affect global temperatures, some more frightening than others. And you can argue about the exact numbers, but the bottom line is that there is a correlation between the use of fossil fuels and our climate. There's a range of sustainable alternatives for fossil fuels. Wind and solar energy, for example, are abundant, and we are becoming increasingly efficient to use their power. However, there's one very important information that I want to share with you. Wind and sun provide us with energy in the form of electricity to power our houses and electric cars, but they cannot provide us with mass, with the carbons, the organic molecules inside. Carbon is essential for making tangible products such as paints, plastic, pharmaceuticals, and currently these come from fossil resources. You don't have to be a chemist to realize that this is where biomass can be a valuable alternative. And this brings us to the bio-based economy, the topic of today. From a fossil-based economy where a lot of products, energy, fuel, and what we see around us is based on fossil resources, we are going to a bio-based economy where we use renewable, non-fossil feedstocks. How would you define the bio-based economy? This definition by the European Commission resembles many definitions worldwide. The source of biomass, as you can see, is quite broad, land as well as aquacultural environments. They are converted into products, energy and public goods. But how does this differ from our current oil-based economy? When oil is combusted, CO2 sealed underground for tens of thousands of years is released into the atmosphere. When biomass is combusted, the amount of CO2 does not increase. This is because the living plants, in fact, also extract CO2 and convert it into oxygen and organic material, in that way realizing a circular economy. The use of biomass can solve a number of problems, and the drivers for this transition can be regarded from different angles. The first is economic. We already saw the uncertainty in the oil price, and you can address this by offering biomass as an alternative source. two is energy security, where uncertainty about the availability of crude oil drives decisions made by politicians. The sustainable production of biofuels from biomass can, for example, circumvent dependence on oil import from foreign countries. Then there is the environmental driver. Studies show that the use of biomass can result in a net lowering of greenhouse gases. We will spend a separate lecture on how this mechanism works, because to evaluate that you need to look at the whole chain, from biomass to transport to production, etc. Next is the demographic driver of a growing and increasingly wealthy population that requires more raw materials. Agriculture is the starting base for most people living in rural areas, and balanced rural development can position the growth of the bio-based technologies and economy in a sustainable manner. The challenge is to foster and innovate bio-based economy that is technically feasible, profitable, and socially desirable. In addition to the provision of food, fiber, and energy, agriculture also contributes to poverty reduction and economic development by providing employment and income from value change. Thus, with food as a driver, we can add sustainable value to the food chain. And I have a very nice picture of that. If you look at the biomass, and here you can see an image of a corn plant, then you see that the nutritional cup can be used for food. But in fact, there is lots of biomass left over, and this material can be valorized into more valuable products. Bio-based products like bioplastics, biomaterials, and biofuels. Meanwhile, the carbon dioxide that is released is incorporated into new biomass. The important message here is that the bio-based economy does not compete with food, but rather includes it. So, what is a bio-based product? According to the European Commission, these are non-food products derived from biomass, such as plants, algae, crops, trees, marine organisms, and biological waste from households, animals, and food production. Bio-based products may range from high-value added fine chemicals, such as pharmaceuticals, cosmetics, food additives, etc., to high-volume materials, such as general biopolymers or chemical feedstocks. I'm sure you all know an example of a bio-based product, whether it's a bio-based Coke bottle or medicinal extracts from plants. And there are actually many, many examples of bio-based products which are produced on a large scale. So what technology is needed to convert all this corn, sugarcane, or wood chips into bio-based products? The answer is biotechnology, and in the next units I will introduce you to this topic.